Okay, good morning. This is Professor David J. De Los Reyes. Okay, the date for this morning will be December 30, 2023. It's almost New Year, okay? My topic for this morning will be, it's a topic on DC circuit, and this could be a problem under those of you who are taking up physics. There is a discussion there, series and parallel circuit. It's just a simple one, but this falls under DC circuit. Okay, let's proceed. My topic for this morning will be a random topic, and this falls under the study of DC circuit. DC circuit meaning the power source is battery, and all the loads are all resistances. So let us try to discuss the problem for this morning. Okay, the given problem is this. We are given a DC circuit. Okay. And the parameters in the DC circuit are these. This is 2 ohm, this is 1 ohm, this is 3 ohms, this is 4 ohms. And the voltage of the power source is 24 volts DC, it's a DC. 24 volts DC. So this falls under DC circuit. The problem is just asking for what will be the total resistance of the circuit. Total resistance, meaning to say if we try to take the single equivalent resistance of this, what will be R total? And what will be I total equal to? I total will be this one. Right? And for R total, it will be something like this. If we try to simplify now, okay, they should be 24 volts, and they should be R total equal to, and they should be I total. So meaning to say, to solve for R total and I total, we must have to simplify the given circuit to something like this, in which this portion here will now be a single resistance in which the value is R total. So if we try to take the simplification of this, the simplification will be this one. Okay, and the problem is asking what will be the value of the total resistance and what will be the total value of the total current if the DC voltage source is 24 volts. Okay, let's try to bring out the solution. So for those of you who are already engineers or are my viewers in the age bracket 35 up, who knows something already about DC circuit, this is for you guys. But for the young ones, if you are only taking your physics, there are still problems that falls under this. It's just a DC circuit. It's not so complicated, but it falls under DC circuit, and that is under DC circuit. Okay, let's try to bring out the solution. To compute for the total resistance of this, we must have to, what you call this, simplify first this portion here. We will start at the far end, this one. What will be the single equivalent of this one? And if we try to see it, for the meantime, assume that this portion here is not existing. Just think of this portion. And if we think of this portion, these two here are in parallel, right? So I place it here. The 1 ohm and 3 ohm are in parallel. Right? 1 ohm and 3 ohm are in parallel, right? So to take the single equivalent, okay, we must have to use a formula. But there is a special formula if the total number of components are only 2. Actually, I derived this one already. But if you are already an engineer, you know that if there are only two components in parallel, the total equivalent will be the product all over the sum, and which it is something like this. To bring out the single equivalent of this, that will be R equivalent equal to, we will be using this formula, and this formula actually emanates from this. Under the study of DC circuit, if there are only two components in parallel, to take the single equivalent, it will be 1 over R equivalent should be equal to 1 over R1 plus 1 over R2. If there are only two components in parallel. Okay, and if we try to simplify this one, 1 over R equivalent equal to, we are adding two fractions on the right in which the denominator are different, so we will be using the butterfly method. The single equivalent will be the product of 1 times R2, that will be R2. And the product of R1 times 1 will be R1. Okay. And the resulting denominator of the compressed value will be the product of R1 and R2. So this is R1 times R2. And if we try to compute for R equivalent, it will be the product R1 R2 over the sum of R1 plus R2. So this is actually the general equation or formula on how to compute for the equivalent resistance of two components which are in parallel. Okay, as long as there are only two components, you can use this formula. But if there is three, that's another thing, right? This is only especially correct or true for two components in parallel. So if we now try to take the single equivalent of this, we will be using this one. So R equivalent will be the product of R1, R2 over R1 plus R2, in which the value of R1 will be this one over here, and the value of R2 will be this 2 ohm. So by using this formula, it will be the product 1 times 3 over 1 plus 3, and that will be 3/4, or this is 0.75 ohm. So the single equivalent of 1 and 3 will be equal to 0.75 ohm. Okay? To compute for the total resistance now, okay, this 0.75, the single equivalent of this one is in series with this 2 ohm here, and so with this 4 ohm. So we will be using the concept of series connection, and which for a series connection, the total resistance will be the summation of the individual resistances. So it will be, the total resistance now will be 2 plus the single equivalent of this, which is 0.75, plus this 4 ohm here, because this 2 ohm plus the single equivalent and this 4 ohm here are now in series. Okay, so the total resistance now will be 2 plus 0.75 plus 4, and the total resistance of the circuit is 6.75 ohms. So this value here is equal to 6.75 ohm. Okay? How could you compute for the current now? Since we know the compressed equivalent of the total resistance is here as 6.75, so it seems we are just given a voltage source in which the total resistance is 6.75. So to compute for the total current, it will just be simply this voltage here divided by this total resistance by using the formula voltage equal to IR, and which we will compute for I, it should be voltage over R. Okay, so applying this equation here back here, okay, we are given the voltage, we are given the resistance. The total applied voltage is actually 24, and the total resistance now, as per our computation, it is 6.75, right? It is over 6.75, and the total current will be 3.56 amperes. That's it. So in here, the concept here is our knowledge on the so-called resistances in parallel and resistances in series, plus the equation voltage equal to IR, that is actually Ohm's law. Okay, so the total resistance will be 6.75 ohm and the total current will be 3.56 amperes. Okay, that's it, guys. So what do you call this? For those of you who would like to follow my channel, my channel is at youtube.com/@ProfDavidJ. Okay, if you want to watch my channel, you could follow that link at youtube.com/@ProfDavidJ. Okay, good morning from Los Angeles. This is Professor David.